Good morning, good afternoon, and good evening, everyone across the globe. Welcome to the International Webinar on Engineering with the theme Cross-Border Engineering Innovation, organized by the School of Engineering, Aurora State College of Technology.
I am Engineer Jeric L. Tangson, and joining me today is Miss Sherry Gay B. Gonzalez. We are truly honored to be your hosts for today's remarkable event, gathering brilliant minds in the field of engineering from all over the world.
Now, to formally open our program, may we all rise, if possible, for the playing of the Philippine National Anthem, followed by the ASCOT hymn and the opening prayer.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, telos ng sinakalan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa mandulupin, di ka pasisitil, sa nagalang tutok sa simoy at sa langit ng bagaw, ay hinatang tulakaw,
Please be seated.
To set the tone of our event, may we now hear the opening remarks from the Dean of School of Engineering of Aurora State College of Technology, Dr. Alking Gorospe.
Hello. Good morning, everyone. And thank you for joining us today for this exciting webinar on engineering cross-border innovation. So, on behalf of the organizers, the School of Engineering, Aurora State College of Technology, and our co-organizers from different institutions, I'd like to extend a warm welcome to each of you, our esteemed speakers, guest speakers, our co-hosts from different universities, and participants tuning in from across the globe. Your presence here reflects a shared commitment to advancing innovation that knows no border. In an era defined by global challenges and rapid evolving technologies, cross-border collaboration in engineering is not just a possibility, it's a necessity. Whether we're building sustainable infrastructure, developing next-generation technology, or tackling climate change, the most impactful solutions are born when minds and sources connected across cultures, disciplines, and nations. Today's webinar is an opportunity to explore how we can bridge gaps in talent, technology, and policy. We'll hear insights from top leaders and practitioners who are already shaping what cross-border innovations look like in practice. From global research partnership to transnational product development and beyond. So we encourage you to be curious, ask questions, and take full advantage of the perspective shared today. Let this session inspire new ideas, new partnership, and renewed sense of purpose in engineering for a better, more connected world. With that, let's get started. Thank you once again for being here and enjoy the session.
Thank you so much, Dr. Gorospe, for your message setting a strong and meaningful tone for today's event. Okay. Now to officially welcome us all, here is a video recorded message from the College President of Aurora State College of Technology, our very own Dr. Renato G. Reyes.
Good morning to all our distinguished guests, esteemed speakers, participants, and friends who are joining us this morning. It is with great pride and excitement that I warmly welcome you all to Aurora State College of Technology's webinar, Cross-Border Engineering Innovation Today. Even as we meet in a virtual space, the spirit of collaboration and discovery remains strong. Innovation knows no more boundaries, geographical or digital, and through this platform, we continue to build partnerships, share ideas, and inspire change together. At ASCOT, we believe that true innovation thrives when knowledge is shared, when diversity of thought is embraced, and when collaboration is prioritized. Today's webinar is a testament to that belief. As we gather brilliant minds and passionate innovators from different places to exchange knowledge and envision the future. May today's discussion inspire fresh insights, open new avenues for partnership, and cultivate lasting impacts that extend well beyond our screens. Thank you for being part of this event. Welcome to Aurora State College of Technology, where innovation and collaboration truly know no borders. Mabuhay and have a productive webinar.
Okay, thank you, Doctor. Thank you very much, Dr. Reyes. Of course, the message of our president reminds us of the importance of fostering global connections and continuous innovation in the field of engineering. Okay, so let's now again hear a message, a video message from the Vice President for Planning, Planning and Finance, Administration, Planning and Finance of Aurora State College of Technology, Dr. Oscar C. Barawid Jr.
To all the participants, distinguished speakers, co-organizers, presidents of the state university and colleges, to our TED Commissioner, the JSPS Executive Director, Bangkok Office, and guests, a warm greetings and a pleasant good morning to all of us. On behalf of Aurora State College of Technology, Office of the Vice President for Administration, Planning and Finance, it is our distinct honor and pleasure to welcome you to the 2025 International Webinar on Engineering with the theme Cross-Border Engineering Innovation. This event marks a significant milestone in ASCOT's ongoing commitment to fostering global collaboration, knowledge exchange, and innovation in the engineering field. As we gather virtually with experts, educators, students, and professionals from diverse backgrounds and countries, we celebrate not only the spirit of academic inquiry, but also the power of engineering to transcend borders and transform societies. Through this international webinar, we aim to inspire creative solutions to global engineering challenges. Number two, to promote interdisciplinary and cross-cultural partnerships. Number three, share cutting-edge research best practices and technological advancements. And last, empower the next generation of engineers to be leaders in innovation and sustainability. We would like to extend our deepest gratitude to all our participants, our partners, our resource persons who have made this event possible. Your presence and active engagement are vital as we work together to shape a future where engineering serves as a catalyst for positive change locally and globally. Let us seize this opportunity to learn, connect, and innovate beyond borders. Once again, welcome to 2025 International Webinar on Engineering. Mabuhay po, and thank you very much.
Thank you so much, Dr. Barawid.
Now at this juncture, we will be hearing greetings from our co-organizers, starting with a video recorded message from the President of Bataan Peninsula State University, Dr. Ruby B. Santos Matibag.
A pleasant day to all of you. To our distinguished guest speakers from esteemed institutions across the globe, to my fellow SUC presidents in Region 3, of course led by our host University President Dr. Renato G. Reyes, to our co-organizers, the Japan Society for the Promotion of Science and the JSPS Alumni Association of the Philippines, to all our cooperating partners and participating universities, to all guests, scholars, researchers, and engineers from around the world, a pleasant morning to all. On behalf of the Bataan Peninsula State University, we are truly honored and delighted to be invited and to serve as one of ASCOT's partners in its noble pursuit of quality and excellence in research. We stand with ASCOT in the commitment to share the latest innovations and insights in engineering that transcend borders and break new ground. At Bataan Peninsula State University, we are excited to be part of this important endeavor of information dissemination and academic exchange. With the rapid evolution of technology and research, it is crucial that we embrace the challenge of advancing engineering innovation. As we explore the latest trends, developments, and discoveries, BPSU reaffirms our shared responsibility to drive engineering forward in ways that are sustainable, transformative, and globally responsive. To all our participants, welcome to this important juncture. May this event inspire all of us to push the boundaries of knowledge, to open new avenues for research, and to forge stronger international partnerships. Once again, congratulations to ASCOT and to all our partners. Thank you very much, and God bless us all.
Thank you, Dr. Matiba.
We are very lucky today because we will hear a message from the President of Nueva Ecija University of Science and Technology, Dr. Rodora R. Hugo. Okay, so wala daw po siya, ano? So, let's move on.
Up next, a message from the President of Occidental Mindoro State College, Dr. Albert Clamor Edaniol. All right, moving on to the next message.
And to give us another message from the President of Pampanga State Agricultural University, Dr. Anita G. David.
Thank you, President Janelle Reyes of ASCOT, to the other SUC presidents, to all the partners and the participants. Blessed morning to everyone. Any academic institution would prepare its engineering students for the industry, and that includes Pampanga State Agricultural University. We commend ASCOT for this endeavor and for inviting us to be its partners. We hope that our students would learn really from the speakers who would be sharing a lot of experiences, a lot of learnings, a lot of results from researches. We hope that the students would be able to use the learnings in their undertakings as students. Again, to ASCOT, the School of Engineering, to everybody in ASCOT, congratulations for this undertaking. And we're happy that you invited us. Mabuhay ang ASCOT, mabuhay ang mga SUC sa Pilipinas, mabuhay tayong lahat. Maraming salamat po.
Thank you so much, Dr. David. Now, we will also be hearing a message from the President of President Ramon Magsaysay State University, Dr. Roy N. Villalobos. All right. For the next message, we have the message from the President of Polytechnic University of the Philippines, Dr. Manuel M. Muhi. Dr. Muhi, are you there? All right. Okay, so another message. Is the chat commissioner here, sir? Okay.
And from the international community, let us hear a message from Dr. Yoshio Otani, Executive Director of Japan Society for the Promotion of Science, Bangkok Office.
Hello, I'm Shotani, Director of JSPS Bangkok Office. On behalf of Japan Society for the Promotion of Science, JSPS, I'd like to congratulate the start of JSP Alumni Association of the Philippines, JAAP webinar series. JAAP started webinar series during the difficult period of the corona pandemic. First webinar series was started in August 2020 with the title of Coping with the COVID-19 Pandemic. The title of the second series was Living in the New Normal and Beyond, which lasted from January to September 2021. When JAAP started the webinar series, we could not know what consequences we would have from the outbreak of the corona pandemic, and we could not have any measures to handle the COVID-19. Some specialists said once the infection rate reached over 80%, the pandemic would automatically cease without implementing any measures. I guess this is a sort of situation right now. After the settlement of COVID-19, some of our daily lives went back to the one before, but some of them never returned to the same as before. We could say only that corona pandemic surely brought many changes in our lives. The biggest product of fighting corona pandemic is online meeting and also work from home. And they became kind of normal at present. Because Philippines is an island country, I suppose it is difficult for JAAP members to see each other face to face and frequently. I hope the new webinar series gives an opportunity for JAAP members to communicate and discuss on a regular basis. I wish the new webinar series provide another new normals to JAAP activities. Thank you for your attention.
Dr. Otani, sending our warm thanks from the School of Engineering, ASCOT, Philippines. Arigato gozaimasu.
All right, that's to all our esteemed guests who shared their heartfelt messages and greetings. Thank you very much for your time, your inspiring words, and of course, your untiring support. Now, your presence today reflects the strong spirit of the collaboration and partnership that drives innovation across borders. We are truly honored and grateful to have leaders like you standing with us as we move toward greater achievements in engineering, education, and of course, innovation.
Now, to give us an overview of today's activity, let us call on the instructor who's been so busy for this webinar. May we call on Dr. Mark Angelo Diaz.
So, good morning, everyone. And welcome to our today's event. This program will bring together distinguished leaders, researchers, and academicians from various institutions across the Philippines, even Japan, Korea, and United States. So we begin with greetings and opening remarks from our esteemed university presidents, as well as officials, and also special guests. So setting the tone for an inspiring day of learning and collaboration. So following this, the main program features a series of insightful presentations by different experts. So we will expecting from the students to ask questions from our three programs especially. So the topics span a wide range of innovations, from advances of composites, materials, AI and engineering, as well as smart agricultural machinery. We also have eco-friendly cooling technologies, and of course the ultrasonic welding from our laboratory or in Korea, as well as the cross-border engineering experiences and climate studies on urban heat islands. Our speaker brings unique perspectives from their specialized fields, reflecting global trends and challenges in engineering, technology, and environmental science. So this event serves as a platform for sharing knowledge, fostering international partnerships, and of course, inspiring the future research collaborations. So we are all thrilled to have you all here, and we hope you to enjoy a productive and engaging session. So thank you for joining us today, and I hope we will learn a lot today.
Thank you. Thank you so much, Dr. Diaz. Now, before we proceed to the next part of this program, let's have a photo opportunity first. All right, and with that, may we request our participants, our organizers, to please turn your cameras, please. And inviting our guests, the faculty and staff of the School of Engineering, to please come here in front for the photo opportunity.
Okay, faculty and staff.
Let's just allot a little space in the middle so that we can see, so pictures may be projected in the middle for the participants and the co-organizers. Yes po. Sir. Dito po yung iba sa kabila. And to our participants inside this room, the students, you can please move forward. Faster, please. Move forward and face the camera at the back. Okay, just face the camera at the back. You face the camera at the back because that's where our camera is. All right. All right. 1, 2, 3, smile. ASCOT's hand sign. Engineering as one. All right. Engineering as one first. Hand sign. And the ASCOT hand sign. All right, thank you very much.
Thank you so much.
First speaker. Our first speaker is Dr. Mazarul Islam Lincoln, composite structural engineer at LIDAM, the Pool Company, United States of America. He will be sharing insights on the topic damage evaluation and detection of composite materials under dynamic loading conditions. Let's give him a round of applause.
Good morning, everyone. Can you everyone see my screen?
Yes, Dr. Lincoln, you are audible, loud and clear.
Okay. Yeah. Again, good morning, everyone. Thank you for the kind introduction and thank you all for being here today. My name is Mazharul Islam Lincoln. I am from Bangladesh and I did my master's in Andong National University, Republic of Korea. Then I did my PhD in University of Massachusetts, Dartmouth, in United States of America. Now I work as a senior composite structural engineer, Latham, USA. Today I am excited to share my research on damage evaluation and detection of composite material under dynamic loading condition. Today I will walk you through the motivation behind my work, the methods I used, key findings, and how they can impact the field. Let's get started. Now, what is composite material? A composite material is a material which is produced from two or more constituent materials like fiber and matrix. And this constituent material have dissimilar chemical or physical properties and are merged to create a material with properties unlike the individual one. Different types of composite material are laminate, laminar composite, fiber reinforced composite, and particulate composites. In this study, we considered the fiber reinforced composite. Now, the composite materials are becoming very popular in electronics, automotive, aerospace, and submarine industries. Automobile structure and wheel rim are nowadays made by composite material, carbon fiber composite. In aeroplane, the composite material are largely used, like Boeing 787, almost 90% of this aeroplane's body are made by composite material, carbon and fiberglass material. And even in submarine industries, composite materials are gaining popularity. Super Falcon 3 submarine made by completely composite material. Now, the composite materials used in different commercial and defense applications demands their superior performance under quasi-static, dynamic, and impact loading conditions. However, mechanical performance of composite materials can degrade in different ways. For example, car accident, bird impacts on the aeroplane, or water impact on the submarine. So there has been significant interest in the recent past in continuous structural health monitoring of composite structure. And this study will provide a better understanding of mechanical performance and damage monitoring capabilities of hybrid composites under dynamic loading conditions. The main objective of this research is to investigate modern dynamic fracture toughness and damage sensing in glass carbon intralaminar and interlaminar hybrid composites. And the strategy we followed is vacuum infusion process is used to prepare the composite specimen. Modified pore props measuring technique is applied to measure the electrical resistivity of the specimen, and a novel fixture is used for dynamic modern fracture loading. Two types of hybrid composites are considered in this study. One is interlaminar hybrid composites, another is intralaminar hybrid composites. Now, what is interlaminar hybrid composites? Interlaminar hybrid composites forms between two different ply, glass ply and carbon ply, and it's stacked one by one to create the composite, hybrid composites. On the other hand, the intralaminar hybrid composites, in a single ply, the carbon and glass yarn are formed evenly, and this even ply stacked one by one to create the hybrid, intralaminar hybrid composites. The material used for this study is TULIP glass fiber fabric, carbon fiber fabric, and thus hybrid glass carbon fiber fabric. And the resin used for fiberglass epoxy resin and hardener. And the multi-ion carbon nanotubes are used to make the interlaminar hybrid composite conductive. Now the composite specimen making procedure. Here vacuum assisted resin transfer molding process are used to prepare the composite specimen. This vacuum assisted resin transfer, the flow diagram is shown here. This black one is a just Teflon board, and this gray one is the composite ply stack, and this composite ply are covered with peel ply, flow media, and the vacuum bag, and the overall system is sealed with a gum tape. Now, from this inlet, resin pass through this composite specimen, and the excessive resin goes out through the outlet. This is a real image of the vacuum assisted resin transfer molding. These are the inlet, and this is the outlet. This black actually the resin, and this portion, this yellow one is the gum tape used to seal the whole system, and here is the composite specimen. Now I will discuss about the experimental setup of this research. This is the setup, those novel fixture to run the dynamic modern fracture toughness experiment, and this is the double cantilever beam specimen. A modified four prop system is employed to measure the piezoresistance response of the composite specimen under modern dynamic loading conditions. Here, silver paint, rectangular silver paint is done on the top and bottom surface of the specimen, and using this silver paint, current pass through the thickness directions, and this right plane of the specimen, here two silver paint is used to measure the voltage during crack initiation and propagation of this DCB specimen. The crack initiation toughness force is measured through a force sensor. This blue schematic diagram is shown as a sensor, and a high-speed camera is used in front of the fixture to capture the whole incident. Now this is the schematic of this fixture. This is the outer frame, then this is the DCB specimen. One end of the DCB specimen attached with this outer frame, and another end is attached with this inner red one frame. And this gray one is a projectile. When this projectile hit this outer frame start moving, and it creates the opening of this DCB specimen. And during this time, this inner frame also try to move, and it creates force on this blue load sensor. And this load sensor is connected with the oscilloscope, which capture this load, which is actually the force initiation toughness. Now, this is the real image of this fixture, and this is the whole entire setup. This is the high-speed camera, oscilloscope, and the fixture and the specimen. Now, this interlaminar hybrid composite, we use two types of interlaminar hybrid composites. One is G-inter, another one is C-inter. The basic difference between these two specimens is these specimens are made by total 10 ply, and the middle ply is glass fabric, and the C-inter composite case, the middle 2 ply is carbon fabric. And for this intralaminar hybrid composite, 4 types of specimen are considered. The first one is Z0C90. The Z0C90 means the glass yarn will be parallel to the crack initiation directions. The opposite is G90C0, here carbon yarn parallel to the crack initiation direction. And the another 2 types of specimen are used, G45, C45. The basic difference between these 2 specimens is both yarn is 45 degree direction in the crack initiation. Now I will discuss about some key results of this research. We did dynamic and static both experiment, but in this presentation I will focus on only the dynamic results. Here the 4 types of intralaminar hybrid composites. Here G90C0 shows the highest fracture initiation toughness. On the other hand, Z45, C45 alternating shows the lowest. And between the interlaminar hybrid composites, G-inter shows the maximum fracture initiation toughness compared to C-inter. Now the question is why the fracture initiation toughness varies among the 4 intralaminar hybrid composites as well as interlaminar hybrid composites. To find out the reason, we did scanning electron microscope analysis on the fracture surface of each composites. This is the scanning electron microscope images of 6 types of composites fracture surface image. The first one is interlaminar G90C0. Here, carbon fiber breakage is the predominant failure mechanism. And this carbon fiber breakage is actually the main reason of showing the high fracture toughness for these composite types. On the other hand, this G0C90 case, glass fiber breakage happens as well as fiber matrix debonding and matrix cracking is also happens. However, no carbon fiber breakage is observed in this composite type. As we know, carbon fiber needs much higher load to break than glass fiber. That's why this G0C90 composite shows less fracture toughness value compared to G90C0. Now, another 2 composite type is Z45, C45 repeating and alternating. These 2 composite case, the carbon yarn and glass yarn are in 45 degree through the loading directions. And this 45 degree layup is not an effective orientation to carry higher load. That's why with a smaller force, the carbon fiber or glass fiber breakage happens because of this ply orientation. And that's why it shows less fracture toughness compared to the first 2 composite types. Now, for interlaminar hybrid composite, the C-inter and G-inter, both composite case, the predominant failure mechanism is fiber matrix debonding. However, G inter shows high fracture toughness compared to C inter. The reason behind it, the fracture initiation toughness equation. If we see the fracture initiation toughness equation, it's directly proportional to the crack mouth opening displacement. Now, the glass fiber is more ductile than carbon fiber, and it can deform more. That's why G intercomposite shows high crack mouth opening displacement, which actually, as it is proportional to glass fracture initiation toughness, so high fracture initiation toughness is observed for G intercomposite case compared to C inter. Now, we know that why this 4 interlaminar hybrid composite shows different fracture initiation toughness and also these 2 types of interlaminar. But why this interlaminar hybrid composite shows lower fracture toughness compared to interlaminar? And to know this answer, we look through the ply formation of these 2 types of composite laminate. Both hybrid composites consist of glass and carbon fiber. However, there is a considerable modern fracture toughness difference between these 2 composite types. And interlaminar hybrid composite shows the higher thickness compared to the interlaminar hybrid composites. Thickness is almost doubled, and this thickness actually creates the high crimp angle. And what is the crimp angle? The crimp angle here is the cross section of a woven unit cell, and this alpha denotes the crimp angle, and crimp angle actually depends on the ply thickness. Now, the interlaminar hybrid composite is thicker, that's why it shows high crimp angle. And from the literature, we know that high crimp angle creates a jamming effect for the propagation of strength across the fiber, which reduces the fabric's breaking strength. Now, as the interlaminar hybrid composites has high crimp angle, so it has less fabric strength. That's why it shows low fracture initiation toughness compared to interlaminar hybrid composites. Now I will discuss the electrofracture response or damage sensing capability of these composite types. Among the 6 composite types, here I will discuss 3 composite types electrofracture response. This load displacement curve are shown in blue color, and the red one is the change in resistance response. And the whole incident is divided into 2 stages, stage 1 and stage 2. In stage 1, no electrical change is observed because in this stage, almost insignificant damage happens in the specimen. This black dotted line actually shows the crack initiation point. Now, after this black dotted line, every specimen's change in resistance increases gradually. The first 3 is dynamic loading conditions, and the last 3 on is the static loading condition of the same specimen. And every specimen, either dynamic or static, you can see after the black dotted line, change in resistance increases gradually, because after that point, specimen starts breaking and its change in resistance actually changes. And from these changes, we can learn that some damage happens in the specimen. That's the main concept of doing this electrofracture response. Now, another basic difference between this dynamic and static experiment is, if you see the peak change in resistance, in this dynamic experiment, all specimens peak resistance change is very high. Here is 200%, 1200%, around 400%, compared to the static. Static change in resistance is very low, around 40, here is 500, and here is 30%. Now, the primary difference between dynamic and static experiment is time. In dynamic test, in this experiment, we consider 40 millimeter crack growth of the specimen. Now, to create this 40 millimeter crack growth, in dynamic experiment, it happens only 7 to 10 milliseconds. Now, on the other hand, in static case, it takes 7 to 12 minutes. It's a considerable time difference. During the crack propagation, the change in conductive network happens faster in dynamic condition. On the other hand, in static case, this crack propagation happens very slowly, which provides an alternative path for the current to flow. That's why change in resistance happens very slowly and the peak resistance change is smaller than the dynamic case. Now I will discuss here the high-speed imaging, how it helps to understand the overall damage initiation and the change in resistance. Here G45, C45 repeating composites, electrofracture response and the high-speed imaging are shown here. Upon the application of opening of the specimen experienced a sharp increase of the force. Around time 1.65 millisecond, crack initiation happens. And before the crack initiation, the change in resistance is very minimal. But after crack initiation happens, the change in resistance increases gradually. And after that, the force starts decreasing. At that time, change in resistance also slowly increase, and compared to the force decrease, a small change in resistance decreases also happens. At that time, crack propagation also happens very slowly, only 2 millimeter, from 3 millimeter to the 8 and 10 millimeter. Only the 3 millimeter change in resistance or the crack growth happens in that time. Now after that, applied force decreases, and also when the second load pulse is applied, again the force actually increases, and the change in resistance also starts increasing. Now after that, again some small peak is observed because of the third and fourth loading, and this is the time when the whole specimen actually break, and the 45 millimeter crack growth happens and complete breakage happens, and we got the peak piezo resistance change around 800%. So this experiment, the main purpose of doing this experiment is to know about how, when the specimen break or creates any damage, how we can understand that damage, seeing the change in resistance. When change in resistance starts increasing, we can understand that any damage happens in this composite specimen or composite structure. Now the key findings of this research is to ply orientation plays a significant role to define composites fracture initiation toughness and damage sensing capability. Interlaminar hybrid composite shows high fracture initiation toughness compared to intralaminar hybrid composites, around 65% increase, and intralaminar hybrid composite shows better damage sensing capabilities, around 800 to 1200% change in resistance, and the proposed modified pore probe method can predict crack initiation and propagation accurately for all composite types. Now in this research, we use intralaminar hybrid composites. The main advantage of this composite is we don't need to use carbon nanotube to make it conductive. We can use this composite directly any damage sensing structure, and we can use this composite in any structure to analyze the damage sensing capability, and also we can do the structural health monitoring. Because the carbon nanotube is very hard to disperse in resin uniformly, that's why it is difficult to make it uniform conductive specimen. But this interlaminar hybrid composites, you don't need to use the carbon nanotube. You can this composite itself can create a good conductive network, which can be used as a good material to structural health monitoring. Now, this interlaminar hybrid composites for G45, C45, 45 degree orientation, this composite ply orientation shows very good damage sensing capability as well as out of plane deformation. And so this material can be a good candidate to make aeroplane wings or the wind turbine blade, and also it can be used as a continuous structural health monitoring of the structure to maintain its structural stability. I will end my presentation here. Thank you for listening my presentation. If you have any question, I will be happy to answer them. Thank you.
Thank you very much, Dr. Lincoln. Now we move on to the question and answer session. Now the floor is open for the questions. To our participants inside this room, if you have question, you can just please raise your hand, stand up before proceeding to your questions. And to our participants online, you can simply type your questions in our chat box. In English, of course, because we have international speakers. Yeah, we do have.
Okay, so we have a student from Mechanical Engineering program. So please state your name.
Good morning everyone. Good morning, sir. My name is JSPS Del Rosario from Bachelor of Science in Mechanical Engineering. So my question is, now that carbon fiber has been utilized in almost every industry, how can we ensure that the production of these materials can't be seen as waste?
Okay. So you mean how we can recycle this material?
Yes, sir.
Okay. Yes, thank you for your question. It's a good question. Yeah, definitely this composite, it's the main concern about these industries, how we can recycling the composite material. It's very difficult to recycling. It's not like easy like metal to recycling. Now for the big industries who are the main user of this composite material, like aerospace industries, nowadays there are several companies to collect those wastage and the recycling. They develop the recycling method to collect those composite material and make it reusable. What they do, they collect those scrap structure and they sorted out those. They actually chopped it and make it a very small fillet or something. The length can be 10 millimeter or even smaller, and they make it as a reusable structure. They may from this chopped carbon fiber they make it as a chopped steel mat or directly chopped glass and chopped carbon fiber. And those chopped carbon fiber can be used in, suppose I work in a swimming pool company. Those company actually use composite material to make swimming pool. So those recyclable carbon fiber and glass fiber can be used in making boat or swimming pool, which is less sophisticated. It's not so those recycling glass and carbon fiber can be used in those industries to reduce the wastage.
Thank you, sir.
All right. Another question, Dr. Lincoln, will be coming from one of the students again inside this room, from Carol Frehinal.
So, good morning, Dr. Lincoln. My question is, what are the fundamental differences in damage mechanism and detection strategies between composite materials subjected to static loading versus dynamic loading? And how do these differences impact the development of predictive models and non-destructive testing protocols?
Okay. The main difference between dynamic and static experiment is here the difference creates because of the matrix we use, the resin. The resin shows some viscoelastic properties. And the viscoelastic properties is like it shows high squeeze material has viscoelastic properties. It shows high stiffness with the high loading rate. Now when this composite material is made of fiber and the matrix, so this composite material also shows some viscoelastic properties. And so when we use it in the dynamic test, it shows more strength and stiffness or need more force to break compared to the static because of the matrix viscoelastic properties. Now that is main difference, and that's the main reason of doing dynamic and static test to see the difference between the same composite specimen. Now to make so is it to constitute a model, you mean to use any kinds of machine learning model or something, you mean, or? The last part of your question, actually, I'm not sure. Do you want to know about how we can make the constitutive model using machine learning, or?
Sorry, excuse me, sir, I can't understand.
Again, Dr. Lincoln.
Hello?
Hello?
Can you hear me?
Yes, sir. What's your last question, Dr. Lincoln?
No, actually, I'm not sure about her last question. Is the constitutive model she means for making using any machine learning model to predict the damage, or I'm not sure about that. That's all. She wants to know any machine learning model, how we can predict those damage.
All right, no worries, Dr. Lincoln. I guess our student here had enough giving or from the knowledge you gave to her. Thank you so much.
Thank you so much, sir.
So, I guess no more further questions from our participants here and in our chat box. All right. Okay, no more questions. So thank you so much, Dr. Lincoln, for that insightful discussion. Now, to show our appreciation, we would like to award the Certificate of Appreciation to Dr. Mazharul Islam Lincoln. So this is the content of the certificate. Republic of the Philippines, Aurora State College of Technology, Barangay Zabali, 3200, Baler, Aurora, Philippines. This certificate of appreciation is given to Dr. Mazharul Islam Lincoln for your dedicated participation as guest speaker in the cross-border engineering innovation at Aurora State College of Technology, ASCOT Hostel, Barangay Zabali, Baler, Aurora, on April 29, 2025. Given this 29th day of April 2025. Signed, Direct Engineer Alking B. Gorospe, Director, Research and Development Office, Vice President for Academic Affairs, Malus or Dr. Malus F. Cabatan, and signed, the SUC President to Dr. Renato G. Reyes. Thank you once again, Dr. Mazharul Islam Lincoln. Now we move on to our second speaker.
Okay, now let's move on to our second speaker. Our second speaker is Professor Yutaka Kaizo, an associate professor at the University of Tokyo, Japan. Dr. Kaizo will be presenting on a topic that reflects Japan's forward-thinking approach to agri-tech, entitled Development of Smart Agricultural Machinery in Japan. So let's give him a round of applause.
Okay, thank you very much. I want to share my screen, but can you?
Yes, Dr. Kaizu, we can see your screen right now.
Yeah, but I cannot share my own screen PowerPoint.
All right, sir.
Give me
Sir?
permission to share my screen. Okay. Now it's okay.
All right, Doc.
Can you see my screen?
Yes, sir.
Okay. Okay, so sorry.
Yes, Dr. Kaizu, your screen is visible.
Okay. So can I start now?
Of course, Dr.
Of course.
Kaizu, the floor is yours.
It's yours.
Okay, so let me start. Thank you very much. Thank you very much, Chairperson. Hello, everyone. Hello. Good morning, everyone. My name is Yutaka Kaizu, joining from Tokyo, Japan. I am very honored to be here today to give this presentation. The title of today's talk is Development of Smart Agriculture Machinery and the potential of small agriculture robots. Before starting the presentation, let me start by showing you this picture. This illustration was published in an American magazine back in 1950, and it depicts how people imagine the world would like in the year 2000. On the other page of this magazine, you could find all sorts of technologies like self-driving vehicles and advanced communications like Zoom we are using now. And this particular image shows the future of agriculture. In this picture, there's an operator, one operator here is who is sending commands to each of the farm machines. You can see machines plowing and sowing seeds, and there is a combine harvester working as well. If you look over here, you'll notice an orchard. And what's really interesting is that there is something flying above the orchard. What do you think it is? I'd guess it's probably a drone with V-shaped wings flying over the orchard for doing some pesticide spraying or some monitoring. Now let me ask you, what kind of agriculture do you imagine we'll see 50 years from now? And this is an unmanned tractor that is currently available on the market in Japan. Yes. And right now, it still has a cabin. The human is operating this tractor. And but that will probably disappear in the future, and just like you see in this conceptual model here. And here is a remote sensing UAV for agriculture. Now it is available. It looks a lot like a drone in the previous slide. Let me briefly introduce myself. I was born in Tokyo, and after completing my master's degree, I worked at Kubota. It is the largest agricultural machinery company in Japan for 2 years. And after that, I became a faculty member at the University of Tokyo and Hokkaido University. And I'm currently based at the University of Tokyo. And I first met Professor Oscar Baravich Jr. During my time at Hokkaido University. My main area of research agriculture, robotics, and biomass energy, and smart utilization of animal power in agriculture. It is my specialty. And let me introduce some more interesting things about the University of Tokyo. Have you ever heard of the dog named Hachiko in Shibuya? It is statue of Hachiko. I think some of you probably know the story. He was a dog who kept waiting for his master in front of the train station, waiting for many years, even after his master had passed away. But on the other hand, not many people know much about his master. Hachiko's owner, Dr. Ueno, who was the first professor of our department about 100 years ago. And this is a bronze statue of Dr. Ueno and Hachiko at our university. And Dr. Ueno is recognized as the founder of our research field, agricultural engineering, here in Japan. And we are very proud of that. Today, I'd like to talk about smart agriculture machinery. Both in Japan and around the world, there are now several types of smart farming machines available on the market. These include fully automated tractors, combine harvesters, rice transplanters, and pesticide spraying drones. In the future, these machines are expected to become even larger and more widely used. However, there are still many agricultural tasks that these machines cannot cover. And this figure shows the range of applications for agricultural robots and smart devices. First, in seedling production, like tissue culture, grafting, transplanting, mechanical devices and robots are already being used. And out in the field, tasks such as cultivation, transplanting, sowing, and crop management, such as irrigation or chemical application, fertilization or weeding, and harvesting. These tasks are done by robotics vehicle, robotic combine, harvesters, and robot transplanter and drones. And robots can also be used for so-called post-harvest operations, such as conditioning, selection, and boxing. In addition, farm management activities like planning, fertilizer management, growth measurements, and yield prediction are also becoming increasingly automated thanks to modern technologies like AI and ICT. And mowing around the farmland, which is very labor-intensive work, is another area where robots are expected to play a bigger role in the future. And also in orchard or greenhouse, most tasks are still done by hand, and these are also expected to be automated in the coming years, like bud picking, fruit thinning, pruning, or harvesting. And personally, I predict that modern humanoid robots will be used more in orchards and greenhouses, where there are lots of narrow aisles. There's also growing need for automated carriers work alongside human workers. Now, let's talk about whether agriculture robots are really feasible. As mentioned earlier, drones and automated tractors, combine harvesters, rice transplanters have already become reality. However, when it comes to fully automating more delicate tasks, such as like weeding between plants, or harvesting fruits, or pruning trees, and managing crop growth, and post-harvest conditioning, we are still at the research stage. Technical and cost issues are preventing the automation. So we know very much that industrial robots have been used very successfully in all kinds of factories for decades. So we tend to think using robots in farming is pretty easy, pretty simple and pretty easy. But many agricultural robots remain at the experimental level. To see why this happens, let's compare industrial robots and agricultural robots. First of all, industrial robots are required to work with very high precision, while agricultural robots also need to be very accurate, but not quite as much. Industrial robot performs repetitive operations, whereas agricultural robots have to handle much more variable tasks. It's very different. Also, the industrial robot usually deal with objects that has uniform shape, while agricultural robots have to handle objects with variable shapes. And also the work environment is very different. Industrial robots usually work indoors and are fixed in a ground, while agricultural robots are used outdoors and are mounted on moving platforms, unstable platforms. Another thing is that industrial products made by industrial robots tend to have a high unit price, automobile or computer or semiconductor. But agricultural products are actually really low in price. Cucumber, tomato, it is very cheap. Also, the number of robots expected to be sold for agriculture is much smaller than the industry. And that means agricultural robots will actually be more expensive per unit than industrial robots. These problems are expected to be overcome by new technology, especially advanced in AI and robotics. However, there can still be major obstacles to the realization of agricultural robots. However, I believe that this is exactly the kind of challenge agricultural engineers like myself should take on. And it's also a great topic for university students to work on. There are a number of issues that need to be addressed when it comes to small agricultural robots. But today, I'd like to share a few examples of what we are working on in our laboratory. First, I will introduce an outdoor robot, a weeding robot for mowing the ridges around the rice paddies. And next, I'll talk about the weeding robot that operates inside the paddy fields. And then I'd like to explain our automatic mowing robot for orchards. And if time allows, I'll also talk about the pick and place robot we are using indoors to help with dried persimmon production. And this pie chart shows how our typical farming group in Japan spends their time on various tasks for paddy rice cultivation. As you can see, the largest portion of time is spent on mowing the grass around the paddy field. We see similar trends among other farmers as well. And other operations are already mechanized. Cultivation and transplanting and fertilizing. And however, mowing also comes with some problems. Right now, most of the mowing along the bank is done using brush cutters like the one shown here. But as you can imagine, this is very hard work and can be quite dangerous. So there is a growing demand for safer and more comfortable ways to mow. And that's where remote controlled or fully automatic robot mowers comes in. And with the help of remote controlled mower, people can operate the machine safely from the distance. In our laboratory, we are developing our weeding robot for slope terrain, like the banks between rice fields. This is a joint research project with Sanyo Kiki, private company. And we built the automatic driving controller using commercially available mower as a base. And for this robot, we use two low-cost RTK GNSS units to accurately measure the both position and the direction even on slopes. With this setup, the mower was able to follow the contour line on the slope with an error of just 7 centimeters. Something that's very difficult to do by hand. RTK GNSS unit used to be very expensive, but now they are much more affordable and are being used for all sorts of applications, like drones and agricultural machinery for navigation. However, there's still a challenge when it comes to automatic travel on slopes around the rice paddies. Here, you can see the typical radio-controlled mower trying to run on a common bank, paddy rice bank. But it couldn't move properly because the banks are often soft and steep, around 40 degrees. So they can even collapse with the soil will collapse when the machine drives over them. And this is an example of a special tractor for sloping terrain that was used in the past, but it was not popular now. we start to wonder, could we prevent robot from tipping over or slipping by changing the shape of tractor's chassis to match the slope, like this tractor? This is a prototype we developed. The body frame of this vehicle automatically tilts to match the slope of the ground. This keeps the center of gravity just between the left and right crawlers at all times. The tilt angle is automatically adjusted in real time by a linear actuator installed here. And we've also installed the inclination sensor here, which allows this frame to always stay perpendicular to the ground. And this video shows our prototype operating automatically on slope. First, here's what happens without any chassis transformation. Because of tilt slope, the center of gravity shifts downhill, making the machine almost tip over. Also, since it's always skidding downhill, we have to keep the nose of the vehicle pointed uphill at all times. Let me show one more time. Now, this video, on the other hand, shows a prototype with tilt compensation. Compared to the case without tilt adjustment, it's much more stable on the slope. Let me show you the video. Skidding is greatly reduced. Right now, we are working on a machine that can handle slopes of up to 45 degrees. And next, I'd like to introduce our weeding robot for paddy fields. Paddy wheel, showing here, is a traditional agriculture tool that was used in the past for weeding rice paddies. These days, you can buy gasoline-powered paddy wheels like this one. We use this as a base machine and equipped with motor-driven wheels. And by using the low-cost RTK-GNS system, the robot can travel between the rows and avoid stepping on the rice plants. Here's a video of the weeding robot operating automatically. Right now, there are two ways to set the robot's route. Let me stop here. Right now, there are two ways to set the robot's route. First, run the robot manually once and record the route. And secondly, detect the position of the rice rows from the drone photos. It's actually quite difficult to keep the robot running smoothly in paddy field because the mud creates a lot of resistance. And the field conditions can vary a lot from the place to place. Another issue is that sometimes the seedlings get crushed when the robot turns, which is also a challenge we need to address. And next, I'd like to introduce more that can be used in orchard. In orchard, GPS signals are often blocked or absorbed by branches and leaves, which makes accurate positioning very difficult. To solve this problem, we are trying to automate the moored navigation using SLAM technology, the same kind of technology used for self-driving cars. And with SLAM, the robot emits the laser beams in all directions. From here, the laser emits all directions. and measures this distance to the surrounding objects, and then estimate its own position and orientation relative to the pre-made map. And this video shows the actual autonomous vehicle driving through the chestnut orchard. Here you can also see a simulation of a simulation of a real-time self-positioning process. The colored points, green and yellow points, represent the 3D map, while the white points around the vehicle are the point clouds data from the 3D LiDAR sensor. By matching the real-time LiDAR data with the map, the system estimates the vehicle's position. And the experiment was very successful in a small area. I'm sorry. We will now explain the result of the autonomous driving. And this figure shows the plot of autonomous trajectory. The blue line is actual trajectory, and the orange line is the trajectory estimated by SLAM. And the error, the RMS error of the position estimation error was 7.2 centimeters. The maximum error was 28 centimeters. Also, this result is slightly inferior to that of RTK GNSS, but we think that the positioning accuracy is sufficient for automatic driving in orchard, and we believe that it has great potential for applications in agricultural work such as mowing, transportation, and harvesting. However, since the path was very simple, we need to conduct many more experiments. We are currently doing experiments with trees in the middle of the pathway and with more large areas. And okay, we still have time. So let's talk about the persimmon robot. In Japan, we have dried fruits called the first step is in making hoshigaki is to peel the persimmon. And while machines are peeling already exist, we have developed a robot system that automatically pick and place persimmon in the correct orientation for the machine peeler. Let's see. And pick up the persimmon here and collect the orientation and set place here, like this. And this video shows how the image processing works. First, the system detects orientation of each persimmon as it moves along the conveyor and delivers to the peeler. To place each persimmon in the correct position and orientation for the peeler, we use image processing based on deep learning. Okay. So let me conclude my presentation. Okay. I'm sorry. Finally, I would like to share my thoughts on the realization of small smart agriculture robots. First of all, drones have been very successful, we know, in agriculture field. But this is a very exceptional case, and the small ground-based robots that I am working on still face many challenges. However, it is not at all impossible to realize. First of all, we need to actively adapt the new technology developed for drones and self-driving cars. And in fact, the sensors required for autonomous driving, such as LiDAR, are steadily becoming more affordable. In addition, it is necessary to improve the performance of battery. A hybrid system and fuel cells can also be used. And we also believe that it is necessary to develop new farming methods. In order to work efficiently with small machines, it will be necessary to develop ultra precise farming methods that performs the necessary work on where it is needed. And we also believe that it is necessary to strengthen the communication networks in rural areas. And finally, we are now seeing the increase in the number of players who develop agriculture robots. Specifically, we are encouraging venture companies and universities, engineering departments, and others who have not have been involved in the agriculture before to become interested in this field and actively participate in it. And I expect that this will broaden the scope of research and produce better products. Okay, this concludes my presentation. Thank you very much for your presence. Thank you very much for your attention. And I'm thinking this is the next generation of power source. And the horse doesn't need gasoline and charging electricity. And it has a great animal intelligence AI. Thank you very much.
Thank you ka muna. Tapos Q&A.
Thank you very much, Dr. Kaiso. Okay, we are now open for the questions. So, anyone here from the students who want to ask a question? Please raise your hand. So, Mr. Ayan. So, please stand up.
Hello po.
Please state your name and where you from.
So, I am Sabrina Romantico. Given Japan technology expertise, my question is, what are the main challenges in developing or implementing smart agricultural machineries in Japan?
There are many challenges in Japan, the most recent achievement in agriculture is very precise transplanting of rice. Usually, now we are automatic driving of rice transplanter is developed already, and it is sold in the market. And the new type of transplanter is that it controls the exact position of each season in the field. That is very new challenge in our field. And we also need to develop the method to decrease the use of water in the paddy field. Now the paddy field use a lot of water, but we are using some special fertilizer. It is called biofertilizer to decrease the use of water. It is very recent topic in our field.
Thank you po.
Is there any question from the students? So, yes, we have Imer Vargas.
Good morning, sir. My name is Emerson M. Vargas. And my question is, how do Japan's smart agricultural technologies compare with those other technological advanced countries?
You mean that, I'm sorry, can you say the question one more time. I cannot get your question very much.
Okay. How do Japan's smart agricultural technologies compared with those other technological advanced countries?
You mean that what's the difference between Japan and other countries' smart agriculture?
Yes.
Development smart agriculture machine is very different in countries, between countries, because in Japan rice paddy is the main crop, so we are mainly focusing on the rice. But in other countries, many other crops like in your country, banana or coconut are very popular products. So in your country, you can develop some smart agriculture machine for that crops. That is a very big difference. But if we have common application, common application in common crops or products, we can share the knowledge in such a machine.
Thank you po.
Thank you. So for our participants on online, you can type your questions dun sa ating chat box. If none, so now let's move on to the awarding of the certificate for our speaker. So let me read the content. Republic of the Philippines, Aurora State College of Technology, Barangay Zabali, Baler, Aurora, Philippines. This certificate of appreciation is given to Dr. Yutaka Kaizo for your dedicated participation as guest speaker in cross-border engineering innovation at Aurora State College of Technology, ASCOT Hostel, Barangay Zabali, Baler, Aurora on April 29, 2025. Given this 29th day of April 2025. Signed, Engineer Alking B. Gorospe, PhD, and the Director of Research and Development Office, and also Malus F. Kabatan, PhD, Vice President for Academic Affairs, signed also by President Renato G. Reyes. So let's give him a round of applause.
Thank you very much.
All right, so we do have a prepared slide presentation for the backgrounds of our speakers. So Dr. Kaizu and Dr. Lincoln already finished presenting their topics, but we still want to show it to our participants, or the whole world rather, to show them that we have international speakers that or who is knowledgeable and with brilliant minds in their specific topics. So flashing now their backgrounds. All right, so as you can see, they have so many experiences in research and so many achievements in the field of research. Now, moving on to our third speaker. Okay, thank you so much, Dr. Kaiju from the Philippines.
Thank you so much, sir.
Our third speaker is Dr. Julius Marvin Vinoya Flores. He is a senior researcher at Sejong University, Republic of Korea. Dr. Flores will share with us his presentation titled AI Applications on Pavement Engineering. So his career highlights, his journal papers, conference papers. Okay, so many conference papers. All right, Dr. Flores, the floor is yours.
Yes, good morning. Aurora State College of Technology. Can you hear me po?
Yes, pa, loud and clear.
I will just share my screen. So basically for today, I will be presenting a topic about artificial intelligence in pavement engineering. Just a little bit of correction po. I am previously employed in Sejong University, but now I am working as a senior researcher in Mujin, which is a company based here in South Korea. I am also have a startup company in the Philippines, which is Pavex Development Inc. It is a pavement management system company serving the Philippines. So I'm not a computer science or computer engineer expert professional, but I am a civil engineer. But we do practice or apply artificial intelligence in civil engineering. So in this morning, I will be presenting its application, AI application, to pavement engineering. So basically, pavement, when we talk about pavement, we are talking of roads and sidewalks. So most of us may know that maybe probably pavement is just used or is just a horizontal structure for people or vehicle to pass by. But actually, the main purpose of having a pavement constructed is to protect the subgrade layer. So we all know the subgrade layer is the earth or the soil. So by creating pavement on top of the subgrade, we are protecting this. Aside from providing comfort to riders and improving the comfort and reducing transportation costs. Because when we construct pavement, we are developing a smoother pathway for the vehicle or the people for easier transportation. That's why we are reducing transportation costs. And also pavement structures serves as a drainage to avoid water accumulation within the structure. So again, the first reason or the main purpose of having a pavement constructed is to provide protection to the underlayers, which are the subbase and the subgrade layers. So when we talk of pavement engineering, it involves several things. It starts from the laboratory mixture design, which starts from the laboratory. So in the laboratory, we determine the optimum binder content or the optimum asphalt content or the optimum water to cement ratio. And after processing or having the mix design finished or established, it goes now to the asphalt plant. So the asphalt plant uses the mixture design that we have developed in the laboratory so that they can manufacture it in bigger scale. So after they manufacture it in bigger scale, construction proceeds. So in the construction, there are compactors, asphalt pavers involved in constructing the pavement. And then after constructing the pavement, pavement engineering doesn't stop there. Pavement engineering starts as soon as the pavement constructed is open to the traffic, because as a pavement engineer, we monitor its life or its rehabilitation methods or options that we can use to prolong its life. So when we are talking of pavement rehabilitation, we want to evaluate first the present condition of the pavement. So we want to know its structural condition, its modulus value, its geometry, if it's thinner or thicker from the previously constructed design, and then what are the ongoing distresses that the pavement is experiencing, such as cracks, rotting. When I say rotting, it's about lubak in Filipino. So we talk about cracking, rotting, pothole, patches, and then everything. So this is what we do in pavement engineering. So in pavement engineering, we monitor or we evaluate pavement distresses. So pavement distresses means the defects that are occurring on your pavement. So again, this can be in the form of cracking, rotting, pothole, and patching, and other forms of distresses that you can see on your pavement. But actually, there are two types of distresses. The one I discussed earlier is only about the surface distress. So surface distress are those we can visually see and cracks and patches on top of the pavement. But we have also this type, which is the subsurface defects, which is not, which cannot be seen by our own eyes because it's ongoing or occurring under the pavement. So it can be in the form of cavities, sinkholes, delamination, moisture accumulation, and more. So again, in pavement engineering, we don't only evaluate surface distresses, but we also evaluate subsurface distresses. So for the surface distress, again, it can be cracking, can be localized surface defects. When I say localized surface defects, these type of defects occurs only in the certain section and not on the whole section. So meaning the failure is occurring on some part of your section. So there is also deformation. This is the lubak or the rotting. Rotting usually due to the underground or the subsurface layer defects. And then we have also structural failure. This is when the current road condition cannot carry the loading that is applied onto the pavement. And we have also repair defects. So usually patching is considered as a rehabilitation method, but actually it's a repair defect because it creates non-homogeneity between the structure. So it only accelerates failure occurrence. So for subsurface defects, we have delamination. So what is delamination? Delamination is the non-bonding of two layers. So for example, your asphalt layer is not fully bonded with the next layer due to tack coat inefficiency or no tack coat application. It can also be due to damage because of moisture accumulation that will eventually lead to moisture damage. So we also have subsurface defects such as subgrade failure. These are the soil erosion, sinkhole, cavity void formation, and lastly, the reflective cracking. So reflective cracking are usually under the surface of the pavement, and we can only see it once it reaches the surface of your pavement. So basically, this type of crack occurs because of these three parameters. The vehicle loading, this is due to the traffic loading. If the traffic loading increases, there is a high chance of distress occurring. And if due to aging, so it means like us as individual, we age. So the pavement or the pavement mixture also ages through time. And also since it's exposed to climatic conditions such as rain, sun, moisture, so climate is also one main parameter in distress occurrences. So I would like to discuss first how cracking mechanism works. So for cracking mechanism, there are two types of cracking. One is bottom-up cracking and another one is top-down cracking. So if the crack initiates from the bottom and it goes up or progresses upward to the pavement, it's called bottom-up cracking. If the cracking occurs from the top and penetrates down to the bottom of your pavement, it's called top-down cracking. But the question is, how can we determine which type of crack is occurring within a pavement? If the crack width is very thick, it's usually a top-down cracking because the cracking starts from the top. But if the crack is very thin, then probably it's a bottom-up cracking. But actually, there's no standard or guideline in determining which type of cracking is occurring onto the pavement. But I would like to discuss why this type of cracking occurs. So for bottom-up cracking, it occurs if you have an insufficient pavement thickness. So what it means is that your thickness of your current pavement is very thin that it cannot handle the current load. So bottom-up cracking can happen. For top-down cracking, it can handle your traffic loading. However, it is exposed to environmental conditions. So it is exposed to weather, to flooding, to water, to heat. That's why top-down cracking happens. So for rotting or lubak, we have two types. It can be due to material failure, and also is due to subgrade failure. So if it is a material failure, usually the rot area is usually higher from the original elevation of your pavement. If the elevation of your rotting is lower than the real or the current elevation, then it's subgrade failure. So if the material fails, it usually the underlayer is still strong. So therefore, this rotting happens, and the elevation profile goes up because there's no defect or deformation going under the layer. But however, since the underlayers are underperforming or failing, that's why the deformation is usually going down for failure to subgrade failure. So another type of failure is the moisture damage. So in the Philippines, we have typically very high chance of rain due to being a tropical country. So if the pavement doesn't have proper drainage, water tends to be accumulated under the pavement between the aggregate layer and the surface layer. And then once it dries up, it creates this void wherein if vehicle or traffic is applied, it will further create scouring or eventually will lead to potholes. So this is how potholes happen. So if we have a material or a pavement that is fully bonded and the drainage capacity is very good, then we don't have, there can be lower chances of pothole occurrences. But again, since the Philippines is prone to flooding, then there is a high chance of pothole occurrences due to this mechanism. Finally, is in pavement engineering, we also measure the roughness. So roughness is the vertical displacement over a certain horizontal displacement. This is usually related or correlated to the comfort experienced by the rider of the vehicle. So this is called the International Roughness Index, which is a measure to determine comfortability and safety of the vehicle. So if we have a very low IRI value, it means the pavement is very smooth and it will lead to hydroplaning. However, if the IRI is very high, it means it's not very comfortable to pass by. So we need to meet a certain threshold for IRI to be accepted. So in pavement management, in pavement engineering, we consider the stress strength, structural capacity, and the surface condition. So the surface condition is the IRI. So in pavement engineering, we do have also the pavement management system. So if in civil engineering we have project management, we also have pavement management in pavement engineering. So when we talk of pavement management, there's different level. There's the strategic level, the network level, and the project level. Strategic level usually is policy making, strategies being done by the higher agency or the national government. For the network level, we usually determine appropriate budget for each region. So for example, in Luzon, so in strategic, we determine the overall need of the government for the road construction. For the network level, we determine the need of each region for the budget or for road construction. But for the project level, we determine the need of each maybe district or each locality for budget for road construction. So these are the types of levels for pavement management system, which requires different tasks and obligations also from the agency. So to discuss the different types of non-destructive testing being conducted to the pavement, so we have the ground penetrating radar. So this type of device, it sends an electronic wave to the pavement, wherein once it reaches a surface or an interlayer that is different from the previous layer, it reflects back to the device. So you can see here, the white one is the transmitted signal and the red signals are the one transmitted back to the receiver. So once the survey is finished, we can have a profile like this, which is called a radargram. So a radargram shows the anomalies under your pavement and shows also the pavement structure. So in this type of non-destructive evaluation, this is evaluating the subsurface distresses. So again, previously I told you that we have surface and subsurface distress evaluation. So we do also have the falling weight deflectometer. The falling weight deflectometer is usually measuring the current structural condition of your pavement. So what it does is it hits the load with an impact loading and it gets the deformation, micro deformation of your pavement. So when we talk about the Hooke's law, if we remember, so we have the stress over strain height. So this simple concept of Hooke's law is being utilized in this device. So if the device hits a loading, there is a corresponding deformation. We know the area of contact, and we also know the thickness of the pavement, so we can determine the modulus value of each layer. So I'm not sure if the participants here are civil engineers, but in civil engineering we have this equation PL over A, which is equal to the deformation. So using that information, we can back calculate the modulus values using the deformation or the deflection values acquired by this device. So how can we apply artificial intelligence in pavement engineering? I just discussed to you the basic concept of pavement engineering. So in artificial intelligence, it can use images, videos, audios, Internet of Things, or different hardware, even documents and database. We can apply artificial intelligence. So no doubt that we can apply artificial intelligence into pavement engineering. So when we talk about artificial intelligence, we simulate or embed human intelligence to our technology. So as I have presented to you, we have the ground penetrating radar, the falling wave deflectometer. So in some researchers, they have applied AI, or they already utilize AI in those devices. So, but in this morning, we will apply artificial intelligence differently. So when we talk of machine learning, it can be supervised and unsupervised. If we talk of supervised learning, we are telling the computer, we are doing some labeling, we are classifying the images into crack. For example, in pavement, we are classifying cracks and uncracked images, and then we feed it to the machine. So in this case, the machine is learning by itself. But for unsupervised learning, we don't classify cracked and uncracked area. We let the computer or the machine learn by itself. So the difference between two types, in supervised learning, there's a high chance that we can get higher accuracy, but the downside is it needs time for labeling the data, and it may tend to limit overfitting. So overfitting means your algorithm works for your database, but once you apply it to another database, it won't work. So for unsupervised learning, you don't need to label data, less manpower needed, but the problem is lower accuracy acquired. So we also have a prediction algorithm. So artificial intelligence, considering prediction algorithm, it means that we have input parameter and we develop a neural network, and then we predict the output. So in this example, we use environmental condition, we use the traffic loading, and we use the pavement structure, and we want to predict black ice occurrence. So black ice is the when there is a formation of thin ice on the top of your pavement. So by considering historical database and the black ice formation, you can develop your own prediction algorithm that you can utilize in the future. So for example, in the Philippines, if you want to predict pavement failure, so you need to have a big historical database of pavement distress occurrence together with different parameters, so that you can develop your regression model or neural network for you to have prediction algorithm. Another one is the detection algorithm. Detection algorithm is the one I earlier shown to you, which uses supervised or unsupervised learning. So in pavement engineering, what we do is we train images like this one, a plan view of a road map, which we detect cracks and non-cracks, or pothole and patching. So after training several algorithms and optimizing your network or your algorithm, you can develop a machine learning program that can detect cracks and classify it into different levels. So currently, our company is utilizing RGB cameras such as GoPro that can take photos and videos at different resolution settings. So we also use laser cameras, wherein the camera will profile the current condition of your pavement to determine if there is a rotting existing or not. We also use drones to detect different distresses. So for example, bridges. So it's difficult to survey bridge, especially under the deck. So we can use drones by attaching cameras to the drone and doing the survey. And then we can also do wireless communication by using Raspberry Pi, attaching to a camera and attaching it to your vehicle. So we can also use, in pavement engineering, we are not limited to pavement alone. We can also use railways as our test bed. So we can attach cameras to drones to do the digital surveying. So using drones, we can survey different types of infrastructure such as bridges, roads, and railway surfaces. So now for the application. So this is a simple application that I have developed using a GoPro camera. So what I did was I used a camera and then choose a survey section, and then I did some algorithm to stitch the images to develop a road map. So in this road map, I applied some algorithm, machine learning algorithm again, to detect cracking, to detect manholes and potholes. So as you can see in this sample, the cracks are detected by the red pixel. So using a very simple and low-cost camera, you can develop your own detection algorithm in the university. So what I did in that one is I have a raw data and I did some background removal. So if I say background removal, we want to focus on the area of our interest. So once we remove the background, we can analyze that area and then we can do some binarization. And finally, we can detect the anomalies or the crack occurrences. So this is another example, crack detection, which we classify the severity levels of the crack from low, medium, high. So we have another type of camera that can profile the pavement, or it can profile the roughness of the pavement, which we need for the International Roughness Index or the IRI. So what it does, it also reflects, once it hits the object, it reflects to the camera, and it uses triangulation in determining the depth or the height of the object. So this one is another algorithm that we have developed to detect localized failure for patching and pothole occurrences. So what we did here was we labeled several images of patching and pothole, so maybe around 2,000 images, and then we trained the model, and then we develop an algorithm that can properly detect the occurrences of such distresses. So maybe in your university, you can try to develop a huge database of pothole and patching, and you can try to apply machine learning. So for moisture detection, so using the ground penetrating radar, we try to find some anomalies with the behavior of the signal. And then using machine learning, we don't need to use another program. We just apply machine learning just to detect moisture occurrences within our subsurface or within our pavement structure. So for delamination detection, same as moisture, we try to find an anomaly within our radargram or our signals. We try to find a pattern that we can feed the machine so that it can learn by itself, so that in the future, once we have future surveys, it can already automatically detect these anomalies within our acquired survey radargrams. So for cavity detection, we have this type of parabolas that we have found that this would mean anomalies. But the problem is some parabolas occurring could be pipes, some occurring could be aggregates. So what we did is we developed an algorithm determining which type of parabola is a pipe, which type of parabola is a cavity, or which type of parabola is an aggregate. And then in the end, we develop a proper algorithm for this detection. So lastly, to end my presentation, actually applying artificial intelligence in different fields of profession is very essential, and it's highly needed as we tend to adapt with the technological advancement ongoing in our society these days. So by combining artificial intelligence, Internet of Things, machine learning, and technology, you can provide or you can develop a more creative approach in solving different problems, especially in this morning I have discussed is in pavement engineering. So I think this will be the end of my presentation. If you have some question, I would glad to entertain. So thank you.
All right, thank you so much, Dr. Flores. We will now be entertaining questions from our participants online and present right now in this room. So, any questions? All right. There's a question here from one of the civil engineering students. Please stand up. State your name first before proceeding to your question.
Hello. And so, good morning, everyone. So, my name is Bill Warrenes Carbon from the Bachelor of Science in Civil Engineering. And based on the topic, the AI application on pavement engineering, which tackles by Mr. Flores, Dr. Flores, and I have a question. And I have a question, sir. So, the question is, can the machine learning models or the machine that the AI predicts the pavement lifespan and the maintenance needs more accurately than the traditional methods?
Actually, that's a good question. Predicting pavement performance can be done not only by machine learning, but usually traditionally, what they do is they do routine inspections. For example, they do routine inspection from January, and then they have a pavement condition index. And then they do another routine survey by July, and they determine the pavement condition index. And they do another routine survey by December, and they can determine again another pavement condition index. And using these routine surveys, the engineer or the pavement engineer can predict or can make or can can develop a regression model that can predict the trend of the pavement condition index. By using machine learning, we can use historical data. So, for example, EPWH has their own database. So, using that one, we can use their database in developing a regression model or prediction model since they have the available data. But the problem is if we apply machine learning using that limited data, there can be a time that the prediction could be wrong. So in machine learning or application of machine learning, we tend to calibrate the machine learning model. It can predict, but for better accuracy, we need to do some calibration. So maybe after 5 years of developing the model, we can have a higher accuracy model. So not an instant that we can develop the machine learning model, but definitely we can have or we can apply machine learning models in pavement prediction and rehabilitation method. Because actually the rehabilitation method, we don't need to apply machine learning, no? Because we need to apply pavement engineering judgment. If we want to develop a human-like decision making for the machine, I think we need to train our model more and more and more. The most important thing about in machine learning naman is you have a huge accurate database. Yep.
So, thank you, sir.
All right, there's another question here, Dr. Flores. Another question from one of the CS students. Okay, stand up.
Good morning, sir. I'm a student from Aurora State College of Technology, taking the Bachelor of Science in Civil Engineering. My question is, how could your research, particularly in surface distress detection and moisture detection, be implemented in wider application here in the Philippines? Thank you.
So, I'm not sure, but anyway, because as we know, as Filipinos, we tend to question every time why the pavement rehabilitation in the Philippines usually done like monthly, like this. So by applying machine learning models, we can standardize the current guidelines being applied by the DPWH. So by applying machine learning in a pavement rehabilitation methods and optimization, we can lower the cost being used by the government in pavement rehabilitation. We can make wiser decisions in pavement rehabilitation, and we can have a more like smoother or better way or better approach of maintaining and rehabilitating our pavement. So actually machine learning can be a huge help in the Philippines because currently, based on my business with other government agencies, usually traditional and conventional methods are being used, and currently the government may be not spend in using AI applications in civil engineering, but maybe in the future it will be very greatly helpful.
Thank you, sir.
Okay. No more questions? I guess that's all, Dr. Flores. Thank you very much.
Thank you.
Now, to give our appreciation to you, sir, we would like to award the Certificate of Appreciation. So let me read the content. Republic of the Philippines, Aurora State College of Technology, Barangay Zabali, Baler, Aurora. This Certificate of Appreciation is given to Dr. Julius Marvin Vinoya Flores for your dedicated participation as guest speaker in the Cross-Border Engineering Innovation at Aurora State College of Technology, ASCOT Hostel, Barangay Zabali, Baler, Aurora, on April 29, 2025, given this 29th day of April 2025. Signed, Engineer Alking B. Gorospe, Director of the Research and Development Office. Signed, Dr. Maluz F. Cabatan, the Vice President for Academic Affairs, and signed, Dr. Renato G. Reyes, the SUC President 3. Again, thank you once again, Dr. Flores.
Okay, now let's move on to our fourth speaker. But before I introduce our fourth speaker, let's have a trivia. So our fourth speaker is former Director of School of Engineering here in ASCOT. So I think you have an idea. Of course, our fourth speaker is Dr. Michael De Leon, postdoctoral researcher of Gyeongguk National University, Republic of Korea. Dr. De Leon will presenting a topic to the future of electric vehicles entitled Ultrasonic Welding of Lithium-Ion Batteries. So, palakpakan po natin. So, as we can see, the researches of our fourth speaker. So, okay, sir. The floor is yours.
Okay, can you hear me?
Loud and clear po, sir.
Okay, so let me just share my screen. Can you see my screen?
Yes, Dr. De Leon.
Okay, so thank you for having me here. So again, my name is Michael. It's nice to be back, see you again. And I'm a current senior research fellow at the Green Fusion Systems Research Center under the Department of Mechanical Robot. So today I'm going to share how the ultrasonic welding is revolutionizing the battery manufacturing for the electric vehicles, and actually how it solved the critical challenges that the other joining methods just can't handle. So as much as possible, I'm going to keep my presentation not too technical. So if you have any questions, you can just write it on the comment section. So here's the current landscape of the battery in electric vehicles. Most of the major automakers, from the Toyota, the Tesla, to the BYD, and to the European cars, are now all in on electric vehicles. Let me just slide this out. Okay, so what is triggering this shift? So this shift is actually moving towards the future applications of green technology, particularly in the transportation. And among the different batteries for electric vehicles, the lithium-ion batteries have the attractiveness of being compact. So they are incredibly energy dense. They can store 3 times more power than the other batteries in the same space. They're also very lightweight. and they last much longer, up to approximately 2,000 charge cycles, and they have low self discharge rate over the course of around 10 years because they only lose about 5% of their charge per month when not in use. So that is why they can deliver the 500 plus kilometer range that the consumers are now expecting. So there are different types of cell. The first one is the cylindrical cell, which is actually the mainstream of the battery cells. This is popularized by the Tesla cars with their 18650 batteries. And another type is the prismatic cell, which has a solid container. It is encased in a solid container, normally made of steels or alloys. And the third type is actually the variant of a prismatic cell, but it is encased in a pouch. So common to all cell types batteries or lithium-ion batteries are actually the stack electrodes, which typically made of tin foils. These are connected to tabs, and among the different cell types, the pouch cell is being considered in electric vehicles due to its lightweighting capability, better volumetric energy density, and of course high spatial efficiency. So this is the current hierarchy of pouch type cell battery pack manufacturing, from the smallest storing component, which is the battery cell, to the battery unit, then to the battery module, and finally to the battery pack. And inside the battery cell are actually series and parallel connections of multiple or ultra thin, some as thin as our hair, and flexible layers of foil electrodes and tabs. And this is how it looks like. So here's the challenge. The manufacturing process of through joining, of course, of these multiple layers of foils to a tab has been very difficult, because we are not just joining it, joining different materials like copper and aluminum. Also, they are different thicknesses, and any single weak joint can compromise the entire battery pack and could disable the entire battery system. So in addition, the poor weld quality, like the unbonded interfaces, the cracks, the defect-related problems, they can cause energy loss by joule heating due to the increased resistance. So therefore, reliable joining for these batteries are very essential for the EV applications. So these are current battery joining technologies for these specific batteries. And when we compare these joining methods, for example, the resistance welding, this struggles with highly conductive materials. And for the laser welding, it needs a perfect alignment, and it also needs a shielding gas. For the mechanical joining, it actually adds more weight, and it can be labor intensive. So why the ultrasonic welding? So it handles the dissimilar materials really well. Also, it can work in a fraction of a second. And crucially, it doesn't create heat-affected zones that can damage the battery components, since it is a solid-state process. So these are the economic comparisons of the different joining processes. And if we look at the tables, the numbers speak for themselves. For example, the UW equipment, it costs less than the other joining methods. It is also aligned with the 170 billion US dollar battery market that is projected by the year 2030. It has a lower direct cost because there are no consumables with this method. It produces less energy than the rest, and it is automation ready, such as in robotic welding, so which is needed for the gigafactories. And companies like the Ford, for example, are already saving millions annually by switching to this method. And lastly, it is sustainable and safe, although there are some hazards, but it is compliant with ISO 26262, which is the functional safety in road vehicles. So as pointed out, among the several joining methods, one stands out is the ultrasonic welding. So as a background, this process was first patented in the 1950s, mainly for tube sealing and wire joining. And then it tried to metallic materials during the 1960s. And recently extended to structural components such as automotive body frames. So ultrasonic welding, or UW, is very capable of welding thin layers and dissimilar highly conductive materials like copper. And it does not require any sealant, inert gas, or any filler metals. And of course, it can avoid the typical metallurgical defects at the heat-affected zone, because technically, it doesn't have any heat-affected zone because the process is within the solid state. So how does it work? So imagine high-frequency vibrations to around 20,000 times per second. So it will create frictional heat, and if we're talking about the metals, we can produce metallurgical bonding. And these are the major components of the ultrasonic welding system. First is the microprocessor, or the generator, that actually transforms the standard AC power of 50 or 60 hertz into high frequency electrical energy of 15,000 to 70,000 hertz. So next is the transducer system, so mainly composed of the converter, the booster, and the horn. So the function of the piezoelectric transducer actually converts the electrical energy into high-frequency mechanical vibrations in ultrasonic range of 20 kilohertz or more. And then the booster will amplify the vibration amplitude to roughly 10 to 100 micrometer displacement. And then the horn will transfer the vibration to the workpiece under the help of the clamping pressure. So the bonding occurs in different ways. The first one can be dynamic recrystallization, in which it involves the fine-grained microstructure refinement. And then another one is mechanical interlocking, in which meshing of the surface asperities within contact. And the last one is about diffusion bonding, in which the bonding occurs at atomic level. So the process, or the basic process of ultrasonic welding, is illustrated here. The workpieces, or the overlap samples, were placed on an anvil, as shown here. And then the horn moves down, and a normal force is then applied perpendicular to the plane of the weld interface. The normal force helps the horn and the anvil maintain contact with the workpieces and hold them together. So the horn will deliver ultrasonic vibrations with enough energy input to increase the weld zone temperature and to achieve plasticization, which results in softening and simultaneous joining. So after the determined welding time, the horn retracts and allows the welded workpieces to be removed from the anvil. So in our laboratory, we are using a lateral drive ultrasonic welding machine from Cormax. So we are using the time control mode. So that welder has a single transducer system in which the oscillation or the oscillating motion is only on one side, or on the horn side. And it has the capability to generate power of up to 3.5 kilowatts maximum at a fixed frequency of 20 kilohertz. So these are the vibration amplitude displacement at different percentage. They tie directly to the energy and power delivered to the weld. So in most cases, it ranges from 20 micrometer displacement to 40 micrometer displacement, and seldom exceed 100 microns. So also the vibration amplitude is an independent variable. It can be set and controlled at the power supply through a feedback control system. So here is a sample demonstration of the process. And that's it. You have the joint. So these are the current lab progress and challenges in UW lithium-ion batteries. In our lab, we optimize the process using the proper design of experiments like the Taguchi method. We are also doing the strength assessment, or the joint strength assessment, using various mechanical testing methods and fracture morphology observations. We also did the reversible joining. This application is particularly for the superconductor or the REBCO superconductor applications. But of course, challenges still remain, like the electro-thermomechanical performance of the joint, which is very important. Also, there are limited data under dynamic loads, particularly on the low cycle fatigue and high cycle fatigue conditions. And joint robustness for high volume EV production is still a concern. And the thermal management under certain environment, like in the cryogenic temperature. And for our current focus, there are topics that we are very interested, such as the reliability across the three critical interfaces of the battery packs, namely foil to tab, tab to tab, and tab to busbar. And for its application, the first joint is about the multi-layered joining of electrode or the foil to tabs. So this is a typical lithium-ion cell, which composed of copper for the anode foil, or known as the current collector, and aluminum for the cathode foil. So a foil to tab weld is needed to gather all the foils inside the battery cell and join them to a tab. So the tab then exits the cell casing, which allows the cell energy to be transferred to an external source. So typically there are two foil to tabs or two foil to tab welds rather in each lithium ion cell, and there are hundreds of cells in a standard lithium ion battery pack. So here we work with high purity materials to mirror the real battery components, with the thickness ranging from 100 microns to 200 microns thick. We use copper with the 99.9% purity, such as the C1220, and aluminum with 99.6% purity, such as the A1050 aluminum. So precision cut were made into shape 50 millimeter, 20 millimeter test coupons. And to replicate actual battery conditions, we created 4 distinct configurations. First two are layered copper to copper joints, known as similar welds, and the other two combining the copper to aluminum stacks, or the dissimilar welds. So the differences varies depending on which material faced the ultrasonic horn during the welding. Since its standardized tests for multi-layer ultrasonic welds don't exist yet, so we developed an evaluation protocol. Joint strength was measured using a custom TPL test that applied controlled peeling forces at 20 millimeter per minute through a 5 kilonewton load cell tensile test machine. So across 3 critical weld interfaces, such as single layer, 2 layer, and 3 layer bands. So electric performance, on the other hand, was equally crucial. And we use a purple method with copper terminal blocks located at both ends and precisely voltage clips. So we calculated the total joint resistance as the sum of the bulk copper resistance and the interface contact resistance. So this setup let us isolate isolates, which is the key advantage of UW since it eliminates the solder-related resistance. So our comprehensive analysis focused also on the weld part temperature, joint mechanical performance, banding and fracture morphologies, and joint electrical resistance. So what is our goal here? Here is the overview of the systematic approach we undertook to characterize the weld quality. Our approach here is comprehensive. We first measure the temperature distributions during welding using an infrared thermal imager. And then we analyze the joint strength mechanically and also the fracture morphologies. And lastly, we verify the electrical performance. So it's this combination that gives us true insight into weld quality. And interestingly, when we compared the UW to solder joints, we found that UW actually performs better despite not using any filler material. So the solder itself, like the indium tin, adds resistance at the interface, something UW avoids entirely. And for the key contributions, first, the lap joint configuration here is very critical. So we have to look at the proper positioning of the tin sheets which directly influences the weld integrity. There are hidden defects challenged here, like UW achieves sufficient metallurgical strength, but it may leave undetected unbonded interfaces, such as voids and gaps, which actually was created from the uniform plastic flow, and subsequently will increase the electrical resistance. So for the electrical performance advantage, the UW exhibit up to 12% lower electrical resistance compared to the solder joints, which is mainly due to the no filler materials involved and, of course, no flux residues. And for the future work recommendations, non-destructive testing is highly recommended here to detect interfacial defects. So for the next joining, this is joining of tab to tab. So one of the essential components in the design of a battery for electric vehicles is the cell packaging of the battery unit. So there are numerous tab-to-tab interconnections in the battery unit. For the tab-to-tab connections, it presents their own challenges. With so many variables involved, testing every possible combination would be impractical. And to address that, those are the complex challenges that we experience. So we optimize ultrasonic weld quality in the battery manufacturing by implementing the Taguchi method. So probably some of you know this method already. So this is a systematic design of experiments that was developed by Dr. Ginichi. So a technique that uses a modified and standardized form of design of experiment that actually balances the efficiency and statistical accuracy. So here, by focusing on three critical parameters, such as the welding time, the vibration amplitude, and the welding pressure, at 3 levels each. So this method allowed us to test only 9 set of welding parameters instead of 27 set of welding parameters for a full factorial design. So meaning it dramatically reduced the time and resource cost. Also, using signal to noise ratios, we simultaneously prioritize 2 competing objectives. The first one is maximizing the mechanical strength using larger is better approach. And the other one is minimizing the electrical resistance with smaller the better strategy. So in addition, the Taguchi analysis can predict the outcomes, which can be validated through confirmatory experiments. And to simplify the assessment, we introduce the strength reduction ratio, or the SRR method. So this was popularized by the research groups from South America and Europe. And this is a metric that comparing the tip strength to the lap shear strength. So this ratio enabled rapid joint quality evaluation without time-consuming microscopic inspections. And beyond immediate results, the Taguchi analysis and its predicted response results and SRR could be valuable for developing optimization models in the future work. So here's the overview of the study. What makes our approach unique? Well, we don't just look at one metric here. So by combining the electrical tests, the mechanical tests, the temperature mapping, and advanced statistical analysis, we get the complete picture of the weld quality. So looking at the morphologies of the surfaces with the tip indentations here in these images and the cross sections, it reveals why the ultrasonic welding works so well. And for the key findings of tab-to-tab ultrasonic welding, through the Taguchi design of experiments, we successfully identified the optimal welding ultrasonic parameters that maximize the mechanical strength while minimizing the joint electrical resistance. So weld quality, on the other hand, was systematically assessed through mechanical testing and electrical analysis, with a strength reduction ratio proving invaluable for rapid quality control, which enables defect detection without doing microscopy by comparing only the TPL results to the lap shear results. And looking ahead, we aim to expand this methodology to multi-layered battery stacks and integrate machine learning for real-time parameter optimization. So moving to the last joint part, which is the tab-to-bus bar. So we face new complexities. These joints must handle extreme currents while surviving years of vibration. making an appropriate evaluation technique essential for the process monitoring and improvement of these joints. And to study this, we built a custom system that monitors electrical, thermal, and mechanical performance simultaneously during the testing. So it gives us a real-time data on how joints behave under actual operating conditions, which is a game changer for the reliability testing. And building upon our previous research experiences and also advancement in the ultrasonic welding research, this study introduces an integrated measurement system designed to address the critical challenge of heat generation in lithium-ion batteries. So for example, the heat accumulation, particularly during the intense charging and discharging cycles, actually compromises the battery efficiency, also their safety, and ultimately their lifespan. So our developed system tackles this by unifying three core components. The first one is precise current delivery to copper terminals via power converters. The second one is through the LabVIEW program, or LabVIEW Control Data Acquisition Module, or DAQ, for real-time voltage or current monitoring during the welding. And lastly is a universal tester synchronizing the load displacement data with electrical signals to generate instant stress strain profiles. So this breakthrough not only enhances the UW, but also informs smarter thermal management strategies for the EV batteries. So again, the aluminum and copper remain the materials of choice for the battery tabs and bus bars because of their superior thermal properties. And to address the challenges during high current operation, we implemented liquid nitrogen cooling at 77 Kelvin during the resistance evaluations, which effectively mitigates the joule heating. So microstructural analysis also via SCM-EDS revealed critical insights, such as the aluminum atoms actually diffuse more actively than the copper during the ultrasonic welding, which is likely due to the higher atomic mobility. But fortunately, the low melting or welding temperature inherent to UW limits the interdiffusion, which restrict the harmful intermetallic compound formation, which is very beneficial to the joint. And for the key contributions of this study, first, this is a multidisciplinary approach, which is the first of its kind. And also, there are critical findings, such as the benefits of controlled tensile stress. For example, by applying around 10 to 15 megapascal of tensile stress, it can practically reduce the joint electrical resistance up to 18%. Also, the thermal management by cooling to 77 Kelvin, which enhance joint conductivity and durability, and its universal applicability with other material combinations. For the practical impact, it can provide actionable insights for the battery pack design and enables rapid reliability testing. And for the future directions, well, we can integrate the AI and machine learning here for predictive failure analysis and real-time parameter optimization. And another one is hybridization, in which combining this UW to other adhesive banding like soldering or the other joining methods. This is particularly related to the fatigue-resistant joints. So where are we taking this technology next? And of course, why it matters for the future of EVs. First, we're going atomic scale, probably using TEM to see what is inside the welds and understand exactly how these bands form at the crystal level. Another thing is artificial intelligence is actually changing the game now. So the models, machine learning, for example, can now predict optimal settings in minutes, not months of trial and error. Next is standardization is key. We are actually creating the first ultrasonic welding testing protocols for cryogenic conditions, which is vital for the next generation batteries. And hybrid approaches are breaking the barriers. By combining UW with smart interlayers, we can reduce brittle pieces by roughly 30% based on our early trials. And how about the residual stresses? We are developing new mappings here, mapping techniques to catch the microcracks before they grow. And for the new frontiers, the UW ferrous to non-ferrous, like aluminum to steel or to titanium, or even to JFRP and CFRP are possible, and also using the continuous sim welding. So those are the breakthroughs. And sustainability isn't an afterthought nowadays. So we are pioneering the fully recyclable UW joints. We first did this with the repo superconductors, and now we're moving to the lithium-ion batteries. But still, the road ahead has challenges. There are still lack of consensus between the different research groups, and standardization gaps are still here. So there are still energy losses. But of course, each of those challenges represent an opportunity. So with the ultrasonic welding, we're not just making the brighter welds here, we are empowering the EV revolution. So I would like to acknowledge our sponsors here. And for my final message, this research is still far from over. There's still much to be done, and of course many efforts to be made. But no matter what comes next, we should always remember that it's not all serious business. So let's just enjoy the process and have fun with our research. So with that, thank you for your attention.
Thank you so much, Dr. De Leon. Now, we will accommodate some questions here from the participants in this room. So any questions? Please raise your hand. Okay, please. Mike. Okay, so go ahead, state your name and where you from.
Good morning po everyone. I am Ezekiel Porbido from Bachelor of Science in Electrical Engineering here in ASCOT. So since Dr. De Leon, you have tackled earlier about the ultrasonic welding and joining batteries, my question is, in terms of efficiency, what is more effective method between ultrasonic welding and soldering when it comes to manufacturing lithium-ion batteries?
Well, currently, both of them are not the standard joining methods for the lithium-ion batteries. The standard ones are the laser welding and the fusion welding, like the fusion weldings, the resistance welding and the mechanical joining. But if we just compare the soldering and the ultrasonic welding, the most efficient is the ultrasonic welding. Okay, it consumes less power, less time, and resources as well. So, yeah.
Thank you, sir.
Another question from the student.
Hello po. So good morning everyone. My name is Patricia May P. Belen from Bachelor of Science of Mechanical Engineering. So here's the question. Among the 4 applications of ultrasonic welding in lithium-ion based automotive battery, what are the best recommended method?
Of course, ultrasonic welding. You mean the... You mean this different welding processes or technologies?
Yes, yes.
Are you talking about this slide, the different joining technologies?
The 4 applications, sir, which is yung joining electrodes to top, joining to top, and joining of top to bus bar.
I see. Okay. So technically the most sensitive one is the smallest unit or the smallest component, which is the battery cell. And it composed mostly of the most sensitive parts like the foils. So the foils actually generates the electrons, the moving electrons, and actually the electrolytes are located also in that particular part of the battery. So among the 4, the battery cell is the most sensitive and of course the most delicate part of the battery.
Okay po. Thank you, sir.
You're welcome.
Again, thank you very much for that very insightful and multidisciplinary. Yes?
Hello, Sir Mike. About the hybrid welding.
Yes, another question from Sir Mark.
Na-optimize na ba natin yung sa hybrid welding? UW hybrid welding. Parang di mo yata na-mention.
Good morning, Dr. Mark. Yeah, nice to see you again. In case of hybrid welding, we optimize ultrasonic welding for superconductor applications, like for the REMCO CC tapes. But for the less sensitive joining, like the copper to aluminum, we haven't did yet the hybridization is not yet fully addressed. So currently, the hybridization method that we are doing is only applicable for the REMCO superconductor applications. We did that by adding the solder with flux or without flux, which is very beneficial for long-term reliability of the joint.
Sige, sir. Thank you, sir.
Thank you. Thank you, Sir Mark. Thank you for that very insightful discussion. So palakpakan mo natin si Sir. To show our appreciation, so we would like to award this certificate of appreciation to Dr. De Leon. So let me read first the content. Republic of the Philippines, Aurora State College of Technology, Barangay Zabali, 3200, Baler, Aurora, Philippines. This certificate of appreciation is given to Dr. Michael De Leon for your dedicated participation as guest speaker in the cross-border engineering innovation at Aurora State College of Technology, ASCOT Hostel, Barangay Zabali, Baler, Aurora on April 29, 2025. Given this 29th day of April 2025, signed Engineer Alking B. Gorospe, PhD, Director of Research and Development Office. Signed, Malus F. Kabatan, PhD, Vice President for Academic Affairs. Signed, Renato G. Reyes, PhD, SUC President 2. So palakpakan po natin. Thank you very much again, sir, for your time.
Thank you so much.
All right, now moving on to our fifth and I guess last speaker this morning, okay? We have Dr. Cristobal Jane P. Rubio, an Assistant Professor 4 at University of Santo Tomas, Philippines. Dr. Rubio will be presenting on a very timely and important topic, a spatio-temporal analysis of urban heat island in Central Luzon, Region 3 from 2001 to 2020. Now flashing the backgrounds of our next speaker, her career highlights, the publication and research contributions, conferences, and of course the industry experience. Let us all welcome Dr. Rubio.
Hi po, am I audible? Can everyone hear me loud and clear?
Hi, Dr. Rubio. Yes po, we can hear you.
Very pleasant morning po. And I would like po to make a quick shout out to all attendees po from Maria Aurora. Baka po hindi nyo napansin, I'm born and raised from Maria Aurora. So kahit po ako ay nag-work in UST, I'm from the province of Aurora also. So I'm placed in a very, very challenging spot. No? I'm in between you and your campus lunch in a few hours or a few minutes. So I try to simplify my presentation so that we can have our lunch on time. So my slide is already shown na po to everyone. So let me start po. This research I'm presenting to you now is one of my initiative for further improvement of study. So as you can see po, this would be an analysis. This is a spatial and temporal analysis of the effect of our patterns of urban heat index in Central Luzon region, where of course Aurora is located, and it would be from 2001 until 2020. So So ang ultimate goal po is somehow to have a correlation between this anomaly and the change in hydrological process in the region, since we are one of, Aurora po is one of the welcoming community pag may dumarating na super typhoons in the country. So let me just quickly define to you what urban heat island effect is. So an urban heat island it's the measurement of the urbanization, which of course replaces all greenery with buildings. So lahat po ng open spaces, we create new buildings. So there will be less greenery, therefore less is the natural cooling system in your region. So the tendency for building up additional area would be your buildings and your roads, which are predominantly made of concrete. This will be absorbing and of course retaining the heat. And therefore it raises the temperature within an area. And this phenomenon would create ultimately an urban heat island. Now you might ask, what's the difference between this and the heat index? Because in Metro Manila, we have here class suspensions whenever the heat index reaches 42 degrees. The heat index is the measurement of how we as humans perceive the temperature. So the air temperature is affected by the humidity, and that's how we perceive the heat index. Okay, so that's the main difference of urban heat island versus the heat index that we see in most of the news nowadays. So the main drive for this research is actually to observe if there's an existing heat island anywhere within the central Luzon region in Region 3. And we will be using satellite imagery. We use actually satellite images from Landsat, and then we use the readily available GIS software, which is QT, so that we can perform the temporal and spatial analysis of these several layers. Okay, so the main analysis conducted in this research involves tracking the changes in the land surface temperature. Again, land surface temperature is different from our air temperature. So we have the index that we use to measure the urban heat island here for this particular research is the Urban Thermal Field Variance Index, or the UCSVI. So we identified several hotspots. If there are any hotspot within the region, what would be the trend in the land surface temperature and the UCSVI. And in time also, do we have more heat islands or heat hotspots within the new year compared to 20 years ago? Okay. So with this drive, our main objective, we focus only with 3 initially. We have just a year in this research. So is there any changes in the heat island? When and where in Central Luzon do we have the highest or the lowest UHI record, and analyze the distribution and potential factors that cause high or even less UTFP. So our scope is, again, I want to highlight that for this research, we use the Landsat layer from the satellite imagery, and the resolution that we use is 30 meter by 30 meters. Every pixel of the satellite imagery is 30 meter by 30 meter. Of course, in the future, we can still improve the resolution of this study. And for a quick graph of everything, so that we can be not very technical, this is our framework based from our reference here. So we gather the imagery from the satellite. So we used Landsat 7 to be particular, and Landsat 7 has several bands starting from B1 to B7, and we gathered or particularly used basics of bands from the Landsat, which is the thermal band for Landsat 7. We performed, of course, reprocessing where we try to eliminate cloud covers and try to integrate, because we downloaded the layers in several blocks first, and then integrated them, weaved them into one. So this is the atmosphere measurement, and then we get the brightness temperature. From there, we can now have an estimation of the land surface temperature, and then we generated the map using the land surface temperature. I'll show you later the formula we used to derive the UTSDI. Then we created several maps for different areas and different years and performed our temporal analysis. Now, to support our conclusions, we tried to further process the other layers of Landsat 7. So we tried to use the land use and land cover indices inside the Landsat 7 bond. We also used specifically the NDVI and the LULC, or the NDVI is the normal different vegetation index. So vegetation index and land use land cover, for us to have a correlation of possible causes why in specific area there would be identified hotspots. So that's the main framework of how we perform this particular research. So the formula is very simple. We pre-process the band 6 of Landsat 7, and then the LST, which is the land surface temperature for each pixel, we pre-process them to compute for or estimate for the UTSDI. Okay, with the UTSDI generated, we now have several maps for specific years. So initially, as we start this research, we had two specific hypotheses. First one is there would be no difference between the UHI parameters, so the land surface temperature and the UTSDI. So we first hypothesized there would be no significant difference. And in fact, for the long-term trend from 2001 until 2020, Central Luzon demonstrates thermal equilibrium. There was very minimal variation both in LST and UTSDI over those 20 years. So there is a temporal stability, meaning there would be occasional peaks of heat intensity observed in some areas and some years, but overall, the urban heat island parameters were stable with very, very minimal change. Therefore, our first hypothesis for this research was supported. So there were no significant difference. Now, our second hypothesis that there would be no difference between urban island areas. So with those 20 years, there would be no changes. So we expect that areas that are not hotspot would remain not hotspot. But unfortunately, of course, Pampanga and Tarlac exhibited UHI hotspots. They had higher thermal intensity compared to other provinces within the region, and it also changed throughout time. In other urban provinces, there were low UHI values, meaning there's no alarming heat islands or heat hotspot areas spotted in other provinces. So our initial hypothesis was not supported by our research. So just so we can have an overview of this is general results, we'll be showing you some of our maps generated. So you can see here, this is the whole Central Luzon region. Aurora is, if this should have been on site, I would ask the students, nasan po ang Aurora dyan? Nasan yung Baler? Nasan? Alam ba nila kung nasan ang Aurora? Aurora is in this area. Okay, the longer part here, this is Aurora province. So you can take into consideration, or maybe of your interest to look into this area. So from 2001 until 2012, this is the land surface temperature process from Landsat 7. So as you can see, by 2020, there's a significant peak in land surface temperature. So there's a very big variability of LST between minimum and maximum value, depending on the year. So in some years, there would be 9, varying from 9 to 46. Others would vary from 15 to 66. And key contributor here would be higher surface temperatures in urbanized areas, of course, because of the buildings, concrete, and then there would be less vegetation. Now for this is just another presentation of the same information, but in a tabular form. So in urban heat island test, we have identified localized, so meaning this is specific to a certain area only, localized thermal stresses by comparing the LST throughout the time. And then there's fluctuation of UTFDI in Central Luzon from by comparing the minimum and the maximum value. Also, the trend here is it's decreasing, significantly decreasing yung minimum value, but the maximum value, although decreasing, the trend is not very obvious as compared to the minimum value. We try to classify the LST and the UTSCI into 6 categories. So we have here 1 being the not alarming, and the 6 identified as hotspot. So if you see a red value in the map, then that means that that area would be considered a hotspot. Okay. Or with a very, very high, this is distribution of the 6 categories of hotspot. Now, maybe we can dwell into Aurora province. So gladly, Aurora province is not qualified as a hotspot, although there are areas under 2 that's still not alarming compared to, of course, let's show the difference between Pampanga here. Pampanga, if you can see, majority of the area in Pampanga falls under number 6, or very, very high heat, urban heat intensity. So it's identified as a hotspot, both with Tarlac, similarly Tarlac. And Zabali is also not a hotspot. So this is the distribution map of the 6 categories from 2001 until 2020. So luckily, our province is still within the minimum category, not so alarming. And shown to you right now is the normalized difference in vegetation index. So this is what we use to somehow justify how come some areas have higher values of heat intensity compared to other provinces. And with this, we have seen that Tarlac and Pampanga were the only 2 provinces since they have very low NVDI or vegetation index. That's why they have high UTFDI value. Now, in terms of land use, this is the land use from 2001 until 2020. It also shows that increased LULC had affected their heat intensity value. The Aurora po has always been under class 1 because we have a wide coverage of grass, Terra Madre. So we have class 1 pa rin po tayo in terms of land use and land cover. So I'm sorry I'm being fast na po kasi magla-lunch time na tayo. So I think the relationship between urbanization and the UHI dynamics that was observed for recently from 2001 and 2002, it's very obvious that with reduced vegetation cover, or if we have high urbanization in an area, and it will be enhancing the possibility of your province to be a hotspot or with high urban heat island probability. And siguro po, you might be asking why a civil engineer would be performing such study. My major po is water resources engineering. And the ultimate goal for this research is for us to ultimately use the data in understanding the change in hydrodynamics of a certain watershed. Because hydrodynamics would be affected by, of course, changes in temperature. So although the majority of the areas are under moderately low UHI range, our study has identified 2 provinces under high UHI category 6 or considered as hotspot. So maybe that's all for My research, I am now ready to work.
Thank you so much. Yes po. Dr. Ruben, maraming salamat po. Now, question and answer session. So, do we have questions here from our participants? Okay, we have one at the back. Okay. You may stand up. All right.
Good afternoon. Morning pala, ma'am. I am Virgie Panganiban po. A teacher by profession but currently working as admin 86 under the School of Engineering. So, I can use English of course, but then because we are in this setting and also I think many are Filipinos, I would like to ask question in our vernacular language, if it's okay. Para po mas maunawaan nila. Okay lang po ba? It's for everyone naman eh. Ang question ko po, since we are here in Aurora po, particularly, the last time I think the highest heat index we had po ay 44 degrees Celsius. And extremely napakainit po nun. Given in our situation po, I've been to Nueva Ecija for quite some time because I taught there in high school. And alam ko po yung heat index sobrang, I hate to say this, but para pong impyerno. Yung init po dito sa Baler, when you come and visit here, nakakasunog po ng balat, especially kapag wala po kayong gamit. Is it high time, ma'am? Maari din po bang pag-aralan kung ilan dapat yung building na itayo, specifically po dito sa Baler? Kasi given yung vegetation namin dito, nababawasan kasi nagtatayo kami ng maraming building. Dapat din ba ma-regulate na, for example, specifically in Baler, Aurora, there should be like something ganitong building lang kasi ito lang yung maliit lang po yung Baler compared to San Luis, one of the bayan dito sa dito po sa buong Aurora. Ngayon po ma'am, mapag-aaralan ba yon para dapat kumbaga 100 lang or 50 lang na buildings dapat para ma-regulate kasi kapag sobra ng dami pwede nang maihaw ang bawat isa sa amin. What do you think po? Given, specifically lang po in Baler, Aurora, ma'am, kasi po, sabi ko nga po sa inyo, iba rin po yung init dito sa amin. Sa ngayon po, sa mga pagkakataon po na ito, ma'am, if you are here, kahit po naka-aircon ka, it feels like, it's like a bit of 1/4 of hell, parang ganon. Kasi po, nakakasuffocate na rin po yung init. What do you think, ma'am? Kasi po, marami na pong buildings dito ngayon sa Baler. That's the only question. Mapag-aaralan ba kung hanggang ilang buildings lang ang dapat itayo, particularly in Baler, Aurora, given yung situation na maliit lang po yung Baler in particular?
Ito po yung kita kong tanong. Our study might have been, Tagalog ito na po, no?
Opo, ma'am. Sure po. Maganda po.
Ang tunay po talagang iniisip namin yung gawin natin ito is just to help us understand bakit nagbabago yung stage ng hydrology. But ultimately po, marami po kasi tayong maps na na-generate and it could be used as reference ng mga policy-making factories. Kung hindi po natatanong, dapat po ang Civil Engineering Office natin sa Aurora, meron po silang master plan for land use. Ibig sabihin po nito, meron na silang mga areas na halimbawa sa Baler po, dahil tumataas yung ito, dumadami po yung sa talaga natin, hindi iwasan, kasamantalayin ng mga kababayan natin yan para magtayo ng potential source of income. So, tatayo ko ng resort, tatayo ng resort, tatayo ng iba't-iba pang pwedeng kainan, at pang pwedeng sumuport sa tourism. Of course, it would improve economy in Baler. Kaya lang, kakompromise na po natin, of course, if you convenience naman. Pwede pong ilan yun, magagawin yung mahal, hindi lang So, ang study po namin can also be a basis ng lahat ng policy-making body, lalo na po yung gumagawa ng mga land master plan. Para makita po nila na, delikado na itong area na to, mataas na yung ng heat or category, therefore, pwede na niyang pigilan na itong area na to, delikado na bilan, pwede magkaroon ng improvement dito, lipat ka ng pinagka. Pwede mo nila gawin ito, ma'am. Kaya lang, sa ngayon po, dahil initial study ko, kung mapansin niyo po, binalik ko kanina, 30 by 30 meters scale po kasi connection bin. Alam ko po kasi yung system na gamit na. Kung meron po sana kami magamit pang other tools, para mas mapalit po namin yung resolution, mas maging mo specific para to smaller area. Dahil maliit nga lang po talaga yung system. Compared to sa Maria, yung ang maraming bayan ng Baler. But ma'am, yes, my answer is yes. Definitely, it would be a great opportunity po if there are some researchers there in ASCOT na tawag po kayo, baka pwede tayo mag-propose to like in OST or somewhere and you can have this research funded and maka-support po tayo sa engineering and land use planning na babae na or bayan sa Aurora bilang isang policy. I would be very glad to see you po. At the best of my life.
Okay, thank you so much, ma'am. Okay po. I'd like to add, ma'am, na kung mapapansin natin in Facebook post, nakalagay po doon, hindi aircon, kundi puno ang solution, which is true. Ang nakikita kasi natin, even, I don't want to make it a political attack to anyone. Wala po akong ganang naisip. Kaya lang, mamang nangyayari dyan, mas marami yung para maging maganda yung kapaligiran natin, pero nagsisuffer naman, and in the long run, we humans are the ones suffering. So sana magkaroon ng study in order for them to, para mababalance lang, na hindi dapat tayo lang ng tayo, dapat dito tanim ng tanim. So yun lang po, thank you so much for your answer.
All right, meron po ba tayong questions? Oh yeah, we do have one from the faculty of the School of Forestry. Yes, sir.
Hello, ma'am. I am Jan Orville P. Bautista from School of Forestry and Environmental Science. Ma'am, ang question ko lang po, kung meron pong factor po ba ang urbanization sa site requirement ng vegetation?
Kung factor po ba ang land use in
Sa vegetation po, ma'am. Sa site requirement po niya. Kasi po, di ba, site requirement.
Ang ano kasi, for this study, again, ang nagawa ko kasi namin, pinagagaling natin namin ng land use na po, galing na po talaga natin. Ngayon, maganda po ito po talaga karoon ka ng site requirement. Ito po kasi ay estimation galing na natin. At pala po yung picture namin, 30 meters. Pero kung magkakasuhan ng measure po sa saan, at measure po talaga ang at na-improve po ito ang model namin na ma-verify, ma-validate. Ngayon po, kung ang tanong ay may relasyon po sa dito po pwede ang ako dito ba minister, dito pwede mo tayo dito kasi ang natinsan, dito pwede mo tayo dito. Yan po pwede, sir.
I mean, ma'am, yung site requirement po nila, kung baga po yung sa temperature, kung bakit po kukunti yung vegetation dito kasi hindi niya namimit yung humidity, elevation.
Yes, sir. Yes, sir. It's another technical aspect. Kaya nga po, one to future thing po po to be mobility to have like kung may people para magkaroon ka ng detail o some photos na these activities sila provide. Pero sir, yan maganda po.
Sige po, ma'am. Thank you po.
All right, thank you. Okay. Do we have further questions? All right, so nakikita naman po natin na it's not just students who are eager to learn and know more about this topic, but as well as our fellow colleagues. So thank you from the faculty of School of Forestry and of course our very own Mom Virgie for your question, and of course for the answer of Mom or Dr. Rubio, leading to a very extremely relevant, timely, and important discussion or insightful discussion. Now, To show our appreciation to Dr. Cristobal Jane Rubio, we would like to award this certificate of appreciation. This is the Content Republic of the Philippines, Aurora State College of Technology, Barangay Zabali, Baler, Aurora, Philippines. This certificate of appreciation is given to Dr. Cristobal Jane P. Rubio for your dedicated participation as guest speaker in the Cross-Border Engineering Innovation at Aurora State College of Technology, ASCOT Hostel, Barangay Zabali, Baler, Aurora on April 29, 2025. Given this 29th day of April 2025, signed Engineer Alking B. Gorospe, the Director of Research and Development Office, signed Dr. Maluz F. Cabatan, the Vice President for Academic Affairs, and signed Dr. Renato G. Reyes, the SUC President of ASCOT. Once again, thank you so much, Dr. Rubio.
You are very welcome po dito sa ASCOT, ma'am.
Okay, and that's it for our morning session. Let's take our lunch break. Okay, kain po muna tayo and we will resume the 5 more presentations of our speakers at exactly 1:30 p.m.
We prepared lunch for everyone. So, sino nagbibigay? Of course, to our participants from the online, happy lunch po. Happy lunch, everyone.
Lunch break po muna.
We will resume at 1 p.m. Tama ba? 1:30 p.m.